So my name is John Leung. I'm on the incubation committee as the liaison to the hardware management project. I'm also a principal engineer at Intel. So what I'm going to talk about is how we're going to actually use these profiles within the context of OCP. And we're primarily focused on how we use it for both the baseline and the server platforms. So this is a presentation a diagram that I presented to the IC regarding my vision of the way we should use the profiles. So what we want to do within the hardware management project is to specify a baseline set of hardware manageability across all OCP platforms. So whether it's a server, storage, network, telco, HPC, we would like Redfish to be the interface that you use to access all of them. And so one thing that the IC came back to me, response was, yes, there will be an OCP profile, but it will not be just a manageability interface. OCP reserves the right to add a whole bunch of other stuff in there when we define exactly what an OCP profile is. So an OCP profile in its eventuality will be a superset in which the manageability interface will be just one part of that. And the way I pitched this was that this is a great vision. We want to start small. So that's why in our initial rendition, we're just going to define a baseline. And then we're going to define server. And we'll go to each of the individual projects and describe what Redfish can do. And it will be at their decision as to whether they want to go ahead and extend it. So I've got traction on storage, that they're willing to go off and do a profile. I've got traction on rack and power. We actually came and said, I've been assigned to go do this. Where should I look? So I showed them sent them to the entire Redfish schema. And he came back and said, well, you have everything described. What do I need to do? I said, well, you just need to figure out what your checklist is going to be for rack and power, and we can get this thing done. So as soon as he comes back with that, we'll generate a profile for rack and power and try to put that through the system. So you've seen this diagram a number of times. I'm going to do it slowly because I wrote it. So the first thing is Redfish is both an interface specification and it's a set of domain models. The interface specification is the standard, use the HTTP, JSON, Python toolchain, and it will define exactly how you get a request to the managed node and how you get that response back. And now it's purely the question, since it's HTTP, what the URI is that you use to get to your resource. And once you do a get on that URI, what does the package look like that you get back? So the package you get back is JSON. And so what the Redfish profile does is since the package that comes back is defined both by the resource that's there and the name value property pairs within the JSON, then you can actually specify all the requirements of Redfish by specifying for each resource what name value pairs are actually returned within your JSON packet. So in this context, I've told DMTF they are a great standards body. They should be able to describe everything, but they have very little prescriptive power. They can tell people what they should do all day long. No one is really going to follow them because the only thing that the industry follows is what shows up on a data center's RFP. So no data center RFP ever says you need to have Redfish. Guess what? No one's ever going to go look at a Redfish spec. But my proposal is that OCP will end up on someone's RFP. They'll say you have to be OCP accepted, and that will drive people. And if we can get Redfish as part of that requirement, then that will drive people to actually look at the Redfish spec and implement it. So I see OCP and other organizations that are having prescriptive power, that they have some notion of ability to specify what must exist within a Redfish implementation. And that's why we invented the profile mechanism to actually make that far more easy to realize. because DMTF has been at this for 20 years, as Hemo said. We've done this many times. And normally we do a waterfall method. We go write the spec, then we go hire a whole bunch of people to write conformance tests, and then we hire a whole bunch of people to run the conformance tests. We decided that was way too slow. So the way we've done it within Redfish is kind of illustrated on the bottom, is that the prescriptive power, OCP, writes a profile. That profile is now ingested and read by a validator, which will test against any implementation. So if this prescriptive power is something other than OCP, that's fine, it doesn't matter. As long as a profile exists, we have a open source validator, which will ingest that profile, that set of prescriptive requirements, and then run against anything that claims to be conformant to that. So you can do that today with the profiles that are specified up there right now. So what we have is in the other room when we're talking about OpenBMC, we have the industry having finally unified OpenBMC under one implementation and one source code tree. And Intel drove that because we wanted to build a Redfish layer on top of OpenBMC. And when we went out there, there were 2 versions that we knew about, and 2 more crawled out of the woodwork as we started figuring this stuff out. So we said, if we're gonna put Redfish on top of OpenBMC, we have to go unify the industry first. So we've done that. There's now actually a branch in the IBM OpenBMC source code tree for Redfish. And I've gotten at least tacit commitment that they're gonna run my OCP profiles against that to make sure at least the first release meets the OCP profiles. So I emphasize this because I think when I presented it again, people said, I didn't figure that out on your first slide. In fact, this entire process, backend process, is now automated. It's no longer waterfalled, and it's at the speed at which OCP can write a profile. Okay, so what does a profile look like? So on the left-hand side is the actual schema diagram of what is part of Redfish. So when you do a get on Redfish v1, you get service root. And from service root, you get a whole list of all its subordinate resources, which tell you, and you can traverse these resources to say, well, I can go to /Redfish v1 /systems /system1 /Ethernet interface, and I can do a get. And that will return me a JSON packet with all the properties of my Ethernet interface for that system. I can go through managers and do the same thing to its Ethernet interface, and it will get me all the properties for its interface that I can now set or define. And so the way I've constructed, since we're going to build a baseline and then extension above it, I said, fine, we'll take this baseline, and the baseline will be composed of chassis, which is the physical sheet metal, and the manager, and a couple of services. And that will be the baseline that will be across all OCP platforms. So, and then servers will be just an extension of that. So they will say, I need baseline, but then server will add the system, which in addition to having logs services and Ethernet services, will also have processors and memory and that type of properties. And the way because we're doing Redfish profiles at the same time I'm doing OCP profiles, what we're doing the format at the same time, I can go back to them and say, I need to do this type of subclassing, right, where I extend baseline and I extend baseline and get the server, and we can go add that immediately to a profile format, how to do that, and the actual validator will soon validate the fact that I'm basically subclassing a baseline to another profile. So as I go to other OCP projects, right, they will define their own rendition of how they extend from the baseline. Okay. So as we go through the baseline, there's been a lot of debate already about where the baseline should be and where the service should be, because the baseline we picked out a point and we drew a line, and now it's at 0.2, so there can be a lot of discussion, because we can put stuff in there which rack and power may not like, or HPC may not like. And for this baseline to be a true baseline across OCP, it's got to be the common subset of everybody's requirements, right? And so we've drawn a line, and that line needs to float until we get feedback from everybody, all the projects, as to where they want that baseline to actually be. Same with servers. So servers, you would think it's fairly simple, except Bill Carter and I had an immediate debate when I specified the server baseline, because I wanted a low baseline. And he wanted the high baseline. He said, wait a minute, Redfish has all this functionality. It has firmware update. It has all this stuff. Why don't I just want all of it, right? We'll put that in a profile, and we'll push that out. And I said, well, that's nice. And everyone will look at it and say, I can't do this. So I'm not part of the game yet, right? So it's a matter of participation and the number of people you actually want to be able to say on day one, I conform to this profile. So the way the DM test has always done things was a little less ambitious, is that we pick the lowest baseline we can to get everyone into the room to say, yes, if you do this, I can have all the server functionality, and I can stand up on stage with you on day one. So right now, the baseline is fairly low. It doesn't have firmware update. But I suspect that once we get people in the room that yes, Redfish works the way it does, and all the tools work the way they do, then you can start cranking up the baseline, the server model, to add additional functionality that all of the server group wants to go off and do. Right? So the way I split up the specifications is we currently have a hardware baseline OCP profile, which is owned by the hardware management project. We have the server profile, which is now owned by the server project group. So they're doing separate reviews to make sure that this adheres to it. Okay. So now it's a matter of going through the profiles and figure out what you want, what was required and mandatory. And this is what Jeff tried to show you. And this is all the functionality that it has. And it does min count conditional, and he flashed through that in about less than 5 minutes, which is pretty good. And so I looked at this and I said, well, I can get each of these projects to actually look at this document and try to understand JSON. Or I could do something easier for them to go look at, that they can actually make decisions about what is required and what is not required. So the way I've written a spec, so you don't have to look at this, and you don't have to understand JSON, and you don't have to count your curly braces. So this is the subset of the document itself. This is actually everything that's contained in every section. It's repeated throughout the section. It basically says, if you have it specifies your resource. It specifies as much of the JSON that you get back as possible. It boldfaces those things that are considered that there is a requirement on. So everything which is not boldface exists and is described, but it's not part of the requirements. And then for each of these which required, I specify there's a table underneath which tells you exactly what that requirement is. And so this, to me, is a far easier format for people to flip through and take a quick look and say, yes, I want this mandatory, or there's some property in here that I actually want that isn't in here that I need to provide feedback on. So you provide feedback on this document like a document, as opposed to trying to wander through the JSON. So for the other, so he mentioned a number of other things that the profile actually expresses. These tables down here are just examples of what, how would they would look in the table. So if there's an if implemented requirement, this is how it looks. That if fans are implemented, the status is mandatory. It's recommended that these other three exist. And then I think an action. So there's always an action property. If there's an action property, it's mandatory. In this case, it's a reset on system. And so if you look at the document that exists now that's been posted as spec, you'll just see this over and over again. So the rest of this, I'm actually going to fly through very quickly. When I went through this in review, it took me 20 minutes to go through the first 2 slides, and people were concerned about the other 10 slides I had in the deck. And I said, everything else is a replication of that previous slide. Because all this stuff, each one of these basically go through the model. So this is the baseline model. This is what's in account service. And if you notice, there's only one thing necessary in account service. It's a list of accounts. Everything else is not needed, but it's there in case the reviewers want to look at it and make a choice that some of this actually gets added. And so I walk through, so this is the session service of how many sessions are being supported within Redfish. This is the chassis resource. So the chassis is, when we define chassis, we just define, both the collection and the singleton. So the chassis resource, a collection resource is just a Oh, how do they do that? Yeah, so that's chassis resource. If you noticed, the chassis resource has links, so it will link to the other resources. So chassis, there's usually a computer system hosted on it, and there's a BMC that manages it. So you can traverse from one resource to another. It's fully hyperlinked, like RESTful should be. There's power and thermal resource underneath chassis. So this is power. And if you notice, there's lots of power telemetry data. We've only listed a couple which are mandatory, which is basically the power reading and the ability to limit the power that's running on that system. The thermal resource, even more data. A lot of it, we have readings which are necessary. I think name is necessary. And if there's a set of redundancies in the system, like power redundancies, we want to make sure that's listed too. And then we're done with chassis, and now we go across to managers. So managers has a log service, which is mandatory, which is where you keep your cell logs. There's a Ethernet interface, because it has a separate interface other than the primary interface, even if it's a sideband interface like Hemel had been talking about, and then the actual network protocol which goes across that. So I'm not going to go through this in a whole lot of detail other than to basically walk through this, what types of resources and properties are needed for baseline. And so this is the Ethernet interface for the manager, which looks identical to the Ethernet interface that's on the system, and that is by intent. When you look at Ethernet interface, it should look the same. There should really be no difference. And so Redfish tries to reuse as much of the models as possible, not only for simplicity, but also for coding simplicity, is that when you find an Ethernet interface, the code that you write to go interpret it should be the same. And then the actual protocol, so your manager can support HTTPS, it can support SSH. If you look at IPMI has a special serial over LAN interface. We threw that away and said, yeah, something already exists, it's called SSH, why don't we just use that and not invent our own? So all this does is the actual protocol enable actually has additional data on exactly what that protocol needs are. So you can just go find the SSH port, which is being exposed by the manager, and be done with it. Okay, and so that's baseline. And so now, if server just extends that, then all they worry about is the computer system, which is hosted over top of that chassis. And so this is your system. System has part number, serial number. It has the ability to boot. It has your power on state. It has your processor summary. It has your memory summary. So we both have both a summary, and then if you want to traverse down to each individual processor, you can state that. The way we've listed this profile is that these summaries are necessary and required, but this need to traverse into each processor and each memory stick is not necessary. So we can change that at a 12, but we've tried to make it as easy for them as possible for what they can do. And then actions at the bottom is that the way we do reset a system is you basically do a post to Redfish v1 system, system1 action reset system, okay? And because there are multiple ways of resetting a system, there is actually a JSON message you can send with it, with a single property, which is what type of reset would you like? Would you like a soft reset? Would you like a hard reset? And to figure that out, you just look at reset action info, which tells you what types of parameters can be passed in that action statement, action post, to this target. So if there's more than just what type of reset, we would have that. Okay? Oh, and then of course, the system has an Ethernet interface also. And so, which takes us to the next steps. So the next steps is you can look at the profiles that exist. They've been posted both at the server project, has both of them, and the hardware management project has both of them. They have files for the spec itself, as I've shown you with the tables, and actually the full JSON. And those are the JSON files that are going to be routed through our validator and our validator when we test against it. Second is the actual description of all the profiles. I think Jeff Otto had mentioned a couple of these. One is the actual profile specification on the actual structure, if you want to understand what the structure of the JSON is. And then what the DMTF did was they actually proposed a set of profiles that OCP could start from. And so that's where we're starting from, so we can start moving the lines based on what the baseline and the server proposals are. And so after the summit, at the summit, you can go attend an open BMC track if it's still available. I think it's on for another half an hour or so. You can visit the DMTF booth in the exhibit hall. And you can visit the various Redfish demos on the floor. So I know Intel has their open BMC implementation, which is always showing. Okay? Any questions? Clear as mud? Good.